Hello and welcome to another free code session. My name is Jason Bach and I can't leave well enough alone. This is becoming one of those issues that I just keep going down a funnel or a black hole or a tornado or whatever you want to call it, a sinkhole. And I just keep rehashing and refining. And I think I'm finally at the point where I can do something here that has a little bit of meaning and then put it to rest. So one of the things I looked at is, well, where am I in my notes here? So you could change it like this. And the thing is that I was sometimes getting these invalid cast exceptions. And what I finally realized is I was getting those because the method as an open generic, you set an expectation or the return function or something like that with a different type for the generic. So you might say, I expect, I have it up here. I think I do, what test it is. Net casting, code generation, here. Yeah. So you're saying I expect the return to be an int, but what you do is you say, I'm going to call it as a string. And again, these are generics on the method. That's not going to match. And so what happens is you get an invalid cast exception, which isn't ideal. So what I'm thinking of now doing is saying, wait a minute, maybe what I should do is then cast the method as like an as and be safer about it. But I'm like, no, but then I, went through this more and I said, well, I think I can kind of do this and do it in a better-ish way. But what I first want to do is say, how much benefit am I getting if I do a cast? So I wrote a couple of tests and I said, what happens if you do an as something and then, return it, a direct cast or an unsafe.as? And as you can see, the unsafe.as is faster, okay, by a large margin. But this is nanoseconds. We're talking really, really small. Then I did it where I'm actually trying to mimic when you do the int is valid with a true or false result. And it's funny because with the true result, I believe that's the true result, the benefit is actually, it looks like unsafe.as is worse, which makes no sense to me. With when it's a false case, I think that's the true case. I can't remember, but like one case is better and one case is slightly worse. But again, we're talking nanoseconds here. In both cases, the direct cast is actually faster. So is this worth it? When I looked at the benchmark test, you could maybe see just a tiniest little blip there, but in all likelihood, you're not going to see any benefit from doing this. And so I kind of said to myself, well, is this really, really worth it? Am I doing anything of benefit to put in this code to do like direct casts or not? Because it's just like, why? Why am I bothering with this? Okay. This is where I talk about, well, this is where I'm getting that invalid cast exception. And then I thought what I could do is in the case where the return type is an open generic, then do a little bit extra work and say, well, if it's a method, then do, and the method is actually of the type, then call method return. Otherwise, get it from the return value that you have here. Otherwise, we'll create a new exception called mock exception and say no return value can be obtained. Okay. And so here's where I'm now kind of landed, which is I could do a couple of things. When you hit a method parameter, or for the return case, I'll have to change the bullet points here, but the point is, if I hit a method parameter and it's an open generic, then I can use the as technique that I'm doing right now before 7.0. Otherwise, keep the code in that I'm doing with a direct cast or change it to unsafe.as. Okay. For the return value, if it's the same tech, then do this technique that I'm saying here. Okay. Generate that code rather than generating this code. So it'd be a little bit more, but not much. Like you'd say if it's an open generic, which in most cases I'd say if it's not an open generic, do this, because my gut is saying more cases than not, you're going to have resolved types. You're going to say it is this type, it's declared as a string or whatever, and you don't need to worry about it being an open generic. But in the case where it is an open generic, you would actually do something like where the result is, you would do something like this. Otherwise, you would do something like that, or one or the other. You know what I mean? Okay. Is it worth it? I'm still debating in my head as I am recording this episode right here in real-ish time. Is it worth doing this? I think at the very least it's worth doing this if you know that the return type is an open generic. Okay. If you know, the parameters that we're checking with the as way of doing things, is that right? This just seems more compact in the sense of, I know if it was a resolve type, I know what it is. I don't have to worry about what it is. And I know the cast, in all likelihood, should work. And so there's this part of me, this adventurous part of me that's saying, let's just do it. Let's put this work in, and let's also use Unsafe.As. Okay. And what I could also do is say, well, if the method itself is generic, and include the namespace if the method is generic. Yeah. Otherwise, no, if the method is not generic, because then we're using Unsafe.As. If it is a generic in any way, shape, or form, then, well, that's not true. Because you could have 3 parameters to a method. You have 1 generic to the method, and that's just defining one of the types. The other 2 will still do the hard cast because they can. You know what the types are on that. Yeah, the only way that we would not include it is if the method was completely open. Like in this case, bar return is completely open. You know, and is completely open is is that worth doing the work to calculate if you had 5 arguments, 5 parameters and 1 return, and you know, how many of those are there? So I'm thinking maybe you just say, always include Unsafe.As. When you're doing direct cast, if you ever catch yourself doing a direct cast, then use Unsafe. So I could do something to say like, well, as I'm going through all the parameters, once I caught something that was an open generic, then I need to add that to the namespaces. Or, and I was thinking about this when I got the mail today, do I just say, put a using in? Just put a using in, you know, right at the beginning of the mock generation. And yeah, if I don't need it, then I don't need it. But again, I'm gambling on the fact that virtually all mocks that I would ever create through this library would use direct casts. And if I tried to make this calculation to say only put in, you know, the namespace for unsafe, then that's probably more work than it would be just to say put the namespace in. And if the code ends up not using it, then that's fine, you know. So with all that said, let's actually do this. So we want to come into here. Let's not back everything out, but what we want to do is let's go up to rocks. Let's go to builders. And again, for makes, none of this matters. None of this matters. So we go to the void builder because we don't have to worry about a return value there. We come down here, and what we want to say is compare. Compare with unmodified, because we want to grab the code that currently was there and put it in here. So if we say the parameter, right? Yeah, okay. If not parameter type is open generic. If it isn't an open generic, okay. Is that a method? Oh, it is. Okay, fine. I thought it was a property. So if it's not an open generic, then we do this. Okay. And, you know, actually what we could do is say, write the line of, if it's not an open generic, we do that. We just save an if here. Whatever. Code, writing code, writing code. Okay. Else, what we're going to do is what we currently did. So we'll go to the end here, grab that. Oh, that's the right line, right? Yeah, okay, and then we're done. So not open to generic, we do the cast, okay? Same thing down here. So we're gonna put that in there. We're gonna say that. Let's come over here and grab this line. Well, except that is that. Back it up, come over here, and put that in there. There we go, okay? And that's it. That's it. So this isn't really a lot of work now, is it? So if it's not an open generic, we can cast it. Now, I'm doing a direct cast here. I'm still not doing Unsafe.As. And the reason why I'm doing this is because I already have the code in place to do it this way. I don't want to necessarily go through Unsafe.As just yet. Okay. So that was that one. Let's go to the value builder. And I bet this is going to be exactly the same. Because I bet, like, I think I lamented about this in the last one. It's like, yep, it's exactly the same. No. Can I code? Can I please do all the coding? And then this becomes that. Okay. So it's method calls and it's exactly the same thing. Okay. Now we haven't done the return. We'll get there in a minute. Let's go to indexer. Let's do the setter first because setters don't have returns. Okay. So same thing here. Okay, we're gonna do a compare with unmodified. We're gonna grab that code there, come out here, and we're gonna say right at that red line, not parameter type is open generic. Can you even do open generics on an indexer? I think I've run into this before. I don't think you can. If I go to Sharp Lab and I say public class index, which is a bad name because stuff. If I say public int this string a get, which we're just going to say returns a 1. Oh yeah, you gotta do that. Okay. But I can't do like this of t and say t. Yeah, unexpected use of a generic. You cannot put generic. So we don't actually even need to worry about this. So I stand corrected. Indexers don't matter. In the sense that, well, what happens if I did index of t? And I didn't make this, but that's fine. I could also make this a t. And we'd say default, just because I want to get rid of it. And that would be fine. So, okay, I stand corrected. We do need to do this, but glad that I remember, because even though you can't define it on the indexer, you would define it, but back up the bus, because we don't support open generics for mocks. You have to say this would be an indexer of string. And so by the time you got down to here, this would not be an open generic, even though it's saying by definition it is. In reality, it isn't. So that's another thing is this a type? Well, it's not saying is generic. It's saying is open generic. Yeah, it just says, is it open or not? And so I'm reading that as just trying to figure out in my head, this means, is it a generic that is open? And I would imagine if you did this, then that wouldn't be considered open. You would know what you're casting it to. And again, we're only doing this for methods, not method generic parameters, not type, because as I just said, Rocks only allows you to mock concrete types. You can't have them be open generics and have that work. So again, I think with the index builder, we can leave it as is because we're doing the casts, and that should be fine. Same with the returns. We don't have to worry about that. Okay. I could be wrong, but I think that's okay. So that takes care of this. Now the return value we haven't done yet. Okay. The return value is only for mock method void builder, because this is where we're trying to get somewhere in here. We're returning things. We're going to return something in this ungodly amount of code. I'm just yelling at myself because I'm like, oh, this is so much fun to debug. Build method, no, because that would be really? No, that can't. That just gives you the, that's casting it to whatever method cast is. And those are the method arguments, which makes sense. So where's this coming from? If method handler method, this is in the void builder. We don't want the, okay, maybe here? Yes, I believe that's right. And we're doing var result, yes. And this is if we should throw does not return exception. Okay, so somewhere in all this mess, which I think I pulled it out enough already that I'm not in a bad spot. Like up here, I had to pause for a second and have my brain reset. Oh yeah, I forgot about these return by ref things, because returns by ref or returns by read only has a whole different set of funness, because you're I forgot what we're doing here. We're returning by ref, yeah. And the only way to do that is I believe you have to hold on to something as a field, what you're returning. As a ref like type, we return that. Phrase events, we throw else, we just return the result. So this is tricky code because of the way you have to handle ref returns and the way that you want to, if you can't throw an exception, like should throw does not return. That's such a great name. So we still do all the work. And then we would eventually come to raising events and increment call count, which you see happens after you do this var result thing. Okay. That's what you're trying to get to, is this var result. Or where you're doing a discard. Okay. What's interesting is, oh, okay. Sorry, it took me a second. This RR is a ref field, but we're still going to do all the work to pull out the value. Okay, if that makes sense, from either method or return value and return value invoke. So yeah, in all three of these cases, we would want to say method is not null. Oh yeah, this gets more complicated than what I'm arguably prepared to think about. So let me just go through this code real here, because this is the heart of the matter. So we'd want to say here, if it is an open generic, is not null, and method is func of whatever that is, whatever the type is you're going to cast it to, is that. Okay. Then instead of calling the method handler method, you're going to call method return. Else, and now you need to say, basically this line now expands out to all three of these. Because you need to, yeah. And so here we're doing return value. I'm thinking in either one of these cases, what I'd actually want to do is do an if here. Like these three up here, I think makes sense to do a ternary. This one only happens if you do the normal direct cast. Otherwise, you need to do method return. So these first two lines, I think, can be handled right. This last one, though, when you're trying to figure out like which handler you're going to use, both those cases then need to be special cased into this. Okay. So actually, I think I got in my head now what the logic is to do here. And that's good. It's just in these three-ish spots. So let's kind of do that. Let's say, if I say method return type is open generic. If it is, if it's not, we do that. Else, what we're going to do is something like this. We're going to grab that and put that in here, except the thing that we're casting, method cast, needs to be done a little bit quicker now. Okay, we need to actually do it up here because we need that. No, just method cast. That's all we need. Okay. Same thing happens here. Okay, else. Except now we need to do that. That. And then, oh, and I got to be really careful because, yeah, here also needs that. Yeah, space that out just to remind myself. Because this will just cast. This, I made a variable here and I need to use method return. So we need to be a little bit smarter-ish. And that. And now the last one, same thing. Let's grab that. Put that in there. Put that there. That. Grab that, except we want that. So that's good. So if it's not an open generic, we can just do the normal thing that we've always done. Otherwise, we're going to do that. Now here, we also need to say, and yeah, I could do a, capture the is open generic thing. Okay, except here, what we're going to do now is just say method return. Okay, we've already indented, and we do that. So now we can pull that back up and that there. Now the only thing left is to now say do this. Okay, and that would happen here and here. So here I would say if the method, if method is not return, it's not an open generic, else what I'm going to do is some fun. Well, by fun, I mean oh my God, I'm doing the wrong things. We're going to do writer dot write lines. Okay. We're going to make that handy dandy extension method work. And write lines, I think I default to tab because yeah, tab is good. Tab is great. Except we need to grab the name of method return type name of type my intent was to say type of T return. That should work though, right? Like that should resolve at runtime and say, well, if you passed in a string, it would say type of T return, which is a string, the full name. I think that should be good. Except you're being too clever. We can't put the type here because this is at compile time. We don't know what it is. We need it at runtime. Okay. Now we're doing this pointer thing or ref-like type in this case. And we need to be a little bit careful here because the thing that we're casting is actually that. And so then I think we can do the same thing here, sort of. I'm going to put that in there, except this now goes here. And what we need to do now is say return value invoke. Boom. Tune in next time to see if any of this had a chance of working, because I'm at my time. Oh, that's so funny. Yeah, I have no idea if any of this is going to work. If it does, then I will consider, and I'll wait till the next episode. I'm not going to run. I'm going to leave this just right here. But the next episode, we'll take a look at it. And if it's shown to actually work, then I will consider adding Unsafe.As. Otherwise, I will just leave them as direct casts. Okay. So again, not open generic. We do it as normal, do it as normal, do it as normal. But this one is cast. Method handler, method handler, method handler. Yep. Open generic, we do it the same way. Otherwise, we say method return because that's what we captured up here, and we just invoke it with the method arguments. Yay, singular code reviews. We do need to pass those in. So that matters. Arguably here, we're just saying, here's the return value. It's actually a funker action. We just say invoke it. So the same thing here. We don't have to worry about the arguments. We're just saying you gave us something back as a handler. We're going to call that and then do that. So yeah, there is some repeated code here. I don't deny that, but I wanted to get the concept in my head out first. So I'm going to leave this. We're going to see if this actually, well, this should at least compile. I don't think there's any, Oh yeah, there are, aren't there? Oh no, those are these little. Yeah, you deleted code. Nothing in rock should fail. Like, I think all that should compile. We haven't changed anything there enough to make rocks yet. So that works. We're going to find, though, if the tests fail or not. So thank you all for watching. Leave comments and questions below. See you in the next episode.